Hello! Today we'll continue our journey into the world of data types in C++. This time we are diving into floating point types, float and double. These types are essential when working with numbers that have a fractional component. So let's break down what they are, their differences, and how to use them effectively in your programs. In C++, floating point types are used to represent real numbers that can have a decimal point. The two primary types we'll discuss today are float and double. Float is typically used for representing a single precision floating point number, while double stands for double precision. But what do we mean by precision? Simply put, precision refers to the number of significant digits a type can represent accurately. When should you use float versus double? If you're working with scientific calculations or financial data, you often need the extra precision that double provides. Float is more suitable for applications where memory is limited, such as in graphics programming or embedded systems, but its precision is lower. For example, float is commonly used in 3D graphics for rendering because it provides enough precision for visual representation while using less memory. Double is used in scenarios like scientific simulations or financial applications, where precision is critical to avoid rounding errors. So, what are the key differences? First, float typically uses 4 bytes of memory, while double uses 8 bytes. This difference in size also means double can store numbers with greater precision and a larger range. But it's not just about size. Precision is defined by something called the mantissa, which we'll cover in more detail shortly. Double has a longer mantissa than float, meaning it can represent numbers more accurately over a wider range. Now, let's dive a bit deeper. A floating point number is typically represented in scientific notation, even in memory. It has 3 parts: the sign, the mantissa, and the exponent. The mantissa, also known as the significand, represents the actual digits of the number. The exponent indicates where the decimal point is positioned. For instance, in the number 1.23e4, 1.23 is the mantissa and 4 is the exponent. This represents 1.23 multiplied by 10 in the power of 4, or 12,300. The precision of a floating point type refers to how many digits the mantissa can hold. A float typically has about 7 digits of precision, whereas a double has about 15. This means that a double can represent numbers with a much greater accuracy. One thing to be aware of is that floating point numbers can't always represent decimal values exactly. For example, try storing 0.1 in a float variable and print it out. You might get a value like 0.100000001. This is due to the way floating point numbers are stored in binary format, which can lead to rounding errors. These small errors can accumulate in calculations, so choosing the right type, float or double, is crucial, especially in applications where precision is paramount. Let's see a quick example of how float and double differ in practice. In this example, we've stored value 0.1 in both float and double. Notice how the float version might show some unexpected digits, while the double version is more precise. When choosing between float and double, consider both the memory constraints and the precision requirements of your application. For general use, double is often a safer choice because of its higher precision, but in performance-critical applications like graphics, float may be more appropriate. That wraps up our initial exploration of floating point types in C++. We've covered what float and double are, when to use them, and why precision matters. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon so you never miss an update. Leave any questions or comments below, and see you in the next video.